Let's do the next one, that is the eighth one. Okay, so that is, show that for any sets A and B, A equal to this, and this A union B minus A is equal to this. So we have to show that these are both are equal and these are both are equal. Okay, so we have two problems here, the first one and this is the second one. So if we want to show these both are equal, then we have to show that this is a subset of this and this is a subset of this. Okay, these are the subset of each other. In the same way, this also, these are the subsets of each other. Then we can prove that these both are equal. Okay, so let's take the first one, that is A equal to A intersection B union A minus B. Okay, so now let's prove that these are subsets of each other. So we'll take first this and prove that to be A, subset of A. Okay, so let us take A intersection B union A minus B. Okay, so now here again, let X be an element, X be an element. Okay, so we can write X belongs to this. Okay, let X belongs to this, A intersection B union A minus B. Okay, see, we can use union, we can use as OR. Okay, we can write union as OR and intersection as AND. Okay, okay, so, and also this minus as we can use as but. Okay, so see, here we can write this as X belongs to A intersection B can be written as A intersection B, U can be written as or X belongs to A minus B. Okay, and again we can write this as X belongs to A and X belongs to B. Okay, or X belongs to A but X does not belongs to B. Okay, A minus B means X, all the elements belongs to A but does not belong to B. Okay, so we can write this as X belongs to A but X does not belong to B. Okay, now see, we have two cases here. Here we have X belongs to A and X belongs to B. Here we have X belongs to A and X does not belong to B. Okay, so here, so finally we need what is A. Okay, so here X belongs to A, so we got X belongs to A. If X belongs to B, that doesn't matter. Okay, let it be, it does belong or does not belong, we don't mind. What we need is A. So here X, we got X belongs to A. Here also we got X belongs to A. Okay, so we have, finally we have X belongs to A. Now you see, we have taken this X belongs to this, now we got X belongs to this, so we can say this is a subset of this. Okay, so which implies A intersection B union A minus B is a subset of A. Okay, so we proved that this is a subset of this. Now we'll prove this is A is a subset of this one. Okay, so now we'll take A. Okay, A. Now so here let Y be an element. Okay, we'll take Y as element here. So Y belongs to A. Okay, now no, let's take another set. Okay, let B be a set. B be a set. Now Y belongs to A and B is a set. Okay, now we can assume that Y belongs to B or Y does not belongs to B, or Y may belong to B or may not belong to B. Let's take the two cases. Okay, if Y belong to B or Y does not belongs to B. Okay, if Y belong to B, then we have taken Y belong to A, we have taken Y belong to B, then these both are having common, so we can write this as Y belong to A and Y belong to B. Okay, or here we have, here we can write this two as Y belong to A. Okay, but Y does not belongs to B. Okay, now here we can write this as Y belongs to A intersection B. Okay, Y belongs to A, because these are both having both common, we can write this as Y A intersection B. Or here this we can write Y is now belongs to A but does not belongs to B. That means we can write this as A minus B. Y belongs to A minus B. Okay, this can again be written as y belongs to A intersection B union A minus B. Okay, so finally we got this. Okay, we have taken y belongs to this and we got y belongs to this, so we can say A is a subset of this one. So A equal to, which implies A is a subset of A intersection B union A minus B. So this was the first one and this was the second one. So by verifying 1 and 2, we conclude what? We conclude these both are equal. Okay, that is A equal to A intersection B union A minus B. Okay, that's it. So let's do now the next second one. Okay, that is A union B minus A equal to A union B. Okay, now let's take this and prove this to be a subset of this. Okay, so again let's take A union B minus A. Now again let X be an element here, be an element. So we can write X belongs to A union B minus A. This can be written as X belongs to A or X belongs to B minus A. Okay, this can be further written as X belongs to A or X belongs to B, but X does not belongs to A. Okay, so again we have two cases here, X belongs to A or X belongs to B. Okay, so we can write this as X belongs to A union B. Okay, so we started with X belongs to A union B minus A. We got this, so we can say this is a subset of this, so which implies A union B minus A is a subset of A union B. Okay, this is the first result. Now let's do the reverse. Okay, let's take this and prove to be a subset of this. Now A union B. Okay, now here let y be an element. Okay, so y be an element, so we can write y belongs to A union B. Okay, y belongs to A union B means y may be in this or in this. Okay, y may belong to this or belong to this, so we can write this as y belongs to A or y belongs to B. Okay, now okay, so now see, we can write this y belongs to B can also be written as B minus A. Okay, we can add another statement, that is we'll write this as y belongs to A or y belongs to B, and we'll add here another statement, that is if y belongs to B but y does not belongs to A. Okay, see, altogether finally we want B minus A. Okay, we have to prove that. Okay, now these both are same, these both statements are same. Okay, y belongs to B or y belongs to B but y does not belong to A, both are same. Okay, so we can write this in this form. Okay, so we can write this again, y belongs to A or y belongs to, this can be written as B minus A. Okay, this can again be written as y belongs to A union B minus A. Okay, so we took y belongs to A union B, we got y belongs to A union this, so this is a subset of this. We have proved it, so we can say, which implies A union B is a subset of A union B minus A. Okay, so we got the second result. So by verifying 1 and 2 results, we conclude that these both are equal. Okay, A union B minus A equal to A union B. Okay, that's it. So proved. Okay, that's it.